Alright, you've now seen everything that the ellipsoid particle emitter has to offer. In this video, we're going to take a look at the mesh particle emitter, which has many of the same properties that the ellipsoid did. As I mentioned in the last video, things like emit, min and max size, the energy, the emission, all of your velocity and angular velocity properties, those are all identical. There are just a few more properties that are pertinent only to polygon meshes, and those are what we're going to focus on here in this video. Now, to get things started, we need some sort of a mesh that we can use. So I'm going to go under my hierarchy view. Let's make sure I'm not playing. I just wanted to double check. Anytime I see motion in the view, I always want to make sure we're not playing. Let's go to create, and I'll make a cube, which is way right up here in front of us. As a matter of fact, let me take my initial particle system that we had a moment ago, and for now I'll just delete it. If I need another one, I'll just make another one, because they're pretty easy to make. Now I'm going to turn this model, this cube, into a particle emitter by going under component, go down to particles, and add a mesh particle emitter. Now, of course, just like with a standard ellipsoid emitter, that's not the entire recipe. We got to go back to component, go back to particles, add a particle animator, and then go back and add a particle renderer, and suddenly we have some particles. Now, just as before, these particles have no material applied. For the time being, I'm going to leave it that way just because the super high contrast of having bright pink particles does make it really easy to see what's going on. So, of course, if you wanted to do something a lot more natural than this, you'd want to come down just like we did before and apply some sort of material into your materials channel within the particle renderer. Again, we're not going to do that here just for the sake of example. So, by default, you'll notice that our particles are being emitted from the vertices of our emitter, and it's going to from the vertices of our mesh emitter. Let's be a little more clear. And just to help us see a little bit more of what's going on, I'm going to add a little bit of local y velocity to our particles. And actually, let me do it this way. This should actually be cooler. Let's set that back to 0. Let's grab world velocity, and I'll set that to 0.5. And then for the fun of it, we'll take our emitter and I'll just give it some odd rotation. And that'll make it real easy to see that it's almost like each one of these vertices is kind of like a little smokestack just pumping out some particles. Now, generally speaking, you may not want to have particles just being emitted from the vertices. It could be that this works just fine, especially if you have a dense mesh. This could be great. But if you have a really low resolution mesh, this could be a little telling. Like here we've got, what, 8 columns of particles, which is kind of silly looking. So if we come down underneath our properties, one of the first unique properties we come into is interpolate triangles. And as soon as we check this, it suddenly looks like we are now emitting across the surface. And that's exactly what we're doing. This tells Unity to start taking the triangles that make up your mesh and interpolate the area of each one of those triangles and start randomly using various spots within the triangle area to spawn your particles. So now instead of just using your vertices, you seem to be using your entire surface. Now, down from here, we have a property called systematic, and this is going to be pretty much impossible for me to clearly demonstrate.
Right. It requires a little bit more advanced understanding of how a mesh is created. And what happens is vertices are maintained in a list. That list has an order or an index at which each vertex is saved. And each vertex. And what it's doing is it's just ordering a particle being spawned off at each vertex one at a time, going to the next one in the list.
That's right. Every single vertex in a polygon model has an ID number. Be it 0-based or 1-based. Your first one could be 1, your next one 2, then 3, 4, 5, 6, 7, 8, 9. They've all got this ID number. Now the catch to this, the trick behind the whole thing, is that in nearly every single modeling application that I'm familiar with, you have no control over this ID. Now, if you wanted to go into the code for a particular model and explicitly set that ID, that's one thing. But for most common practical uses, you won't have any control over this ID. It's just going to happen. But what this does, what the systematic checkbox does, is we spawn a particle, we emit a particle from ID 1, then ID 2, then 3, then 4, then 5, then 6, and so on and so on. If you have 500 vertices in your model, it'll do that. 1, 2, 3, 4, 5, all the way up to 500. And only after ID number 500 gets an emission, then we wrap back around to 1 and we continue. Again, but because in most modeling apps you don't get that control over what vertex is labeled what, it may not be the most useful thing in the world. So let's go ahead and turn that back off. Now down from here we have normal velocity. This is how quick, or a random range. This is what velocity we want to impart based on the normal of the surface. Now, this gets a little interesting to look at if we leave this set to vertices. This still works, but let's set it to, I don't know, let's say 1 by 1. And you can see we're firing off based on the normal, but it's a little bit hard to read. It's actually a little easier to read if you are also interpolating the triangles. Because now, especially if I was to, let's just zero out the rotations of our cube. So I'll come up here to rotation, and let's just set this to 0, 0, 0. Give that a moment. I'm also going to increase my overall emission.
Well, take off the roll velocity as well.
Yeah, that's the next bit. Because we're also pushing everything up a little. And I just want to increase my emission so we get a little bit kind of thicker swath of particles. And you can see what we're doing is we're firing particles out along that face normal.
Right.
So it's just a way to push particles away from the surface. Now, in the case of something like a cube here, we get this really consistent division over which direction the particles go. The more rounded your model happens to be, the more kind of natural and flowing this emission might be. So it's something that is going to be very dependent on how your object is created. All right, now moving down from here. Next, we have the mesh that we are actually using. Now, because I applied this already to a model, this mesh is in here. If we wanted to use any other model that we may have loaded in, all you would need to do is click on your little load button here, and you can use any mesh that might already be in your project. So if you have, the model of your spaceship already in there, or maybe just a specific particular part of its engines, you could just select that, drop it into the mesh property, and that is the mesh that will be used for emission. Now, there is one last thing I do want to mention, and that is tangent velocity. Now, let's set all this stuff back to 0. So we're just kind of spawning particles all over the surface, so they're not doing really anything but dying. I just wanted to point out that at the time of this recording, tangent velocity is not going to do anything meaningful for a mesh emitter. So if you're playing with that and you're not getting any value or any reaction at this point, don't worry. That's just how it's working at the moment. So that is all of the unique properties. That's a rundown of all of the unique properties for a mesh emitter, which is going to wrap things up for this video. Thanks a lot.